Hello. Today, let's talk about Copenhagen interpretation and many worlds. The world as we have known for the past century and more has been deterministic, but the oncoming of quantum mechanics shook our understanding of the deterministic universe. In order to understand how quantum mechanics makes this world probabilistic, we need to understand the notion of superposition. And in order to understand what superposition is, we will take a look at Young's double-slit experiment. In Young's double-slit experiment, light is proven to have wave-like properties. Till the time, the double-slit experiment was not done with anything else. It was believed that light was unique and it exhibited both wave and particle properties. However, when G.P. Thompson and Davison and Germain conducted the experiment with electrons, it was proven that all matter had both particle and wave-like properties. Now that it had been proven that all matter exhibits wave properties, the same experiment also led to another understanding. If in the double-slit experiment an electron acted like a wave and as matter, then it would mean that instead of going through only one slit, it would actually be in superposition, where it is going through both slits like a wave, only to go through one of them upon measurement. Now that we understand what superposition is, we ought to take a look at the famous Schrodinger's cat thought experiment. The setup is as follows. A cat is placed inside of a box, alongside a jar of poison that will break if a hammer, which is connected to a radiation sensor, detects radiation from an atom decaying. Now the experiment goes as such. If the atom decays, radiation triggers the apparatus, thus killing the cat. Whereas, if it doesn't decay, the cat lives. According to quantum mechanics, the atom is constantly in the state of superposition of both decayed and not decayed. This is given by the Schrödinger equation, and only when we open the box to measure the outcome does the wave function collapse, giving us a clear result. This means that while the box is closed, the cat is both dead and alive. Although the idea that the cat can be both dead and alive simultaneously is just a thought experiment, it is fascinating. The wave function, which describes the probabilistic state of the system, tells us that the square of the wave function's amplitude is directly proportional to the probability of observing the particle in a specific state. In this case, whether the atom is decayed or not, leading to whether the cat is alive or dead. This leads us to a crossroad. The above interpretation of a wave function only collapsing once we observe it means that the world is probabilistic, due to there being a certain probability of observing a particle according to its wave function. This is known as the Copenhagen interpretation of the world. It's important to note that the wave function collapse is a conceptual interpretation within the Copenhagen interpretation, not a physical process occurring to the particle itself. The fact that the outcome is decided at the time of observation and the lack of explanation on the role of the observer causes many oppositions. Another explanation for the Schrödinger's cat thought experiment, which I personally prefer, will take a bit more explanation. As we saw in the Copenhagen interpretation, whether the cat lived or died depended directly on the atom, and if by the time it was measured it had decayed or not. To explain it in a clearer sense, the atom state was entangled with the detectors, which in turn was entangled with the state of the hammer and hence the state of the cat. This is a brief and very simplified explanation of quantum entanglement. Quantum entanglement occurs at an atomic level, which means that there is technically one singular wave function for the world, as the state of all atoms is entangled with each other. With this knowledge, if we proceed further, then the atom is entangled with the radiation detector, which is also entangled with the hammer, the poison, the cat. And now, the cat is entangled with the air surrounding the cat, which in turn is entangled with the box. And the box is entangled with the air surrounding the box, leading to the atom ultimately being entangled with you. And this explanation leads to the possibility of parallel worlds. As soon as you observe the system and in turn measure it, the wave function of the atom collapses and you see one of the possible states. But that is just you. There is another you, which is simultaneously observing the other state at that moment. This can be a bit mind-boggling, but this theory, called the many worlds interpretation, solves the issues of the observer role by making it so that there is no role of the observer, as the observer is also entangled with the atom. This also solves the issue of the world being probabilistic, as with the many worlds interpretation, the deterministic nature of things is just confined to the world you're situated in. There are many nuances with the many worlds interpretation too, and this is just the tip of the iceberg. There are numerous other interpretations as well, such as the pilot wave theory, but we shall discuss that another day.